Here's another projectile motion problem. A cannonball is shot from the top of a 30-meter high hill at a velocity of 25 meters per second at an angle of 40 degrees above the horizontal and lands on the ground below. The speed of the cannonball at the top of its path is most nearly, so we have a cannonball that is shot from a high hill that is 30 meters with a velocity of 25 meters per second at an angle of 40 degrees. Now, so the cannonball went up, so it's gonna follow this projectile. It's gonna go up and then it lands here on the ground there. The question is asking us to solve for the speed of the cannonball at the top of its path. This is actually a tricky question, but a very simple one. We need to solve for the velocity of the projectile at this point here. Now, what do we know about the projectile? We know that at this point here, the projectile's vertical velocity is actually 0 because once the object is at its maximum height, the vertical velocity is 0. On the other hand, our Vx, this is actually constant. And Vx can be solved using the equation Vx is equal to Vi cosine theta. So meaning to say the velocity of the object at the highest point, at this point, is in fact equal to the horizontal velocity, because this horizontal velocity is constant. It is only the vertical velocity that is 0 as the object goes from this point up to the maximum height, but then its horizontal velocity remains constant. So to solve this problem, we just have to use equation Vx is equal to Vi cosine theta, and in fact that is the speed of the object at the top of its path. So we substitute Vi is equal to 25 multiplied by cosine of 40 degrees. Vx is equal to 19.15 meters per second, so therefore it is most nearly equal to 19 meters per second. This is the answer to this question.